Okay. Hello, welcome to my talk about the Qtcreator for microcontroller development. I think so, yes. Okay, is it loud enough? Yeah? Okay. Okay, perhaps a little bit about me. I started embedded development when I was 15 on 80 C535. And I'm doing mostly embedded stuff with embedded Linux, but this is a side project of mine, and well, yeah. So what I'm going to talk about today, I'm giving you or probably I'm just doing a quick overview. What's the background of my people here? Who has used Qtcreator? Okay. Quite a lot, okay. Okay, then you probably know quite a lot about it. Have you used Eclipse? Okay. Code blocks? Okay. Yeah, I'm giving a short overview of a Qtcreator. I'm going to show you what the bare metal plugin for the Qtcreator gives you, and I'm giving you an overview over the improvements of the bare metal plugin, and I'm going to do a short hands-on presentation afterwards. Okay, what's Qtcreator? Qtcreator is a main development environment for the Qt project, so it's mainly has been coming from desktop development nowadays. It has a lot of development options for cross-platform development. Internally, it has a modular design, so everything is implemented by plugins and so on, and it's cross-platform. So for the host platform, you have the main desktop targets, and you have a lot of targets nowadays for desktop, mobile, embedded Linux, and bare metal. So you have quite broad options what you can develop on and to. Okay, I think you probably know most of the stuff given your background, so I just highlighting for me the best features Qtcreator has. It's fast navigation, so you have a code model behind, which nowadays has also an experimental, or is it? I don't know if it's not experimental by now, but it's also more sophisticated but slower code model based on LLVM. And you can switch between both depending on if you like more. If you're using more modern C++ features, probably you're better off with the LLVM code model, but well, they're both pretty good in my opinion. Well, you've got syntax highlighting, code checking as you type, auto-completion, code folding, context-sensitive help, but you have to do some work to have your own code with context-sensitive help, because you have to create the Qt specific help files, which can be done, but it's quite a bit of work to do. And you have parenthesis matching, so it's easy to navigate with parentheses and so on. And personally, what I also like, I just didn't put it on the slide over here, is that you have a VI mode for typing, so you don't type any weird stuff as you used to if you're using the VI mode stuff. So if you have any questions or so, just interrupt me. I'm happy to answer your questions. There have been some new features in 2014 for the Qtcreator. That's support for Android development. The client code model I just talked about. C99 support has been improved, like lambda expressions, designated initializers and some stuff more. You have column editing, so you can do some block editing and stuff like that on multiple rows. One thing that's a misfeature for the embedded stuff is that you need an GDB with Python support enabled, because they dropped support for GDBs without Python scripting support, which is mainly bad for the people working on non-Linux platforms. Okay. So, yeah, what's bare metal development anyway? It's for the small class chips. The main chips on the market are the ARM Cortex-M or R class devices. I think they are the most popular. They have only a few K of RAM and flash, and they're all built up on one chip, which means they're pretty cheap nowadays. So given that they are so small, you normally need a hardware debugger to talk to them. They have no or only lightweight operating systems. So if you're using an open source hardware debugger, what I'm using is OpenOCD. I would recommend to use a FreeRTOS, which has the task support built in by OpenOCD. So currently the list is ECOS, FreeRTOS, ChiBOS, or AMP kernel. And if you have some other, if you're developing on embedded Linux stuff also, you don't gonna use the bare metal plugin, because you can use remote Linux debugging, which is also very good supported in Qtcreator, but I'm not going to talk about that here. But it's working for several years now, so that's nothing new. Okay, the bare metal plugin is basically adding support for hardware debuggers in Qtcreator. That was the only thing that's missing. You have a pretty good editing stuff and all the IDE stuff you're expecting, but this was a small part missing. And to get this up and running, a few things had to be added to the Qtcreator. The Qtcreator itself organizes its targets by kits. So a kit is a set of compiler, debugger, and devices you put together. And with this kit, you then have a target defined for your debugging purposes. So by adding a new bare metal kit, it's possible to add support for hardware debuggers. And with this kit, you also need a bare metal device, which has also been added by the bare metal plugin. And there are now GDB server providers, which I'll talk about later, which make debugging a little bit more comfortable. Okay, I will show that later on in a hands-on. So just this quick start, how you start bare metal debugging, and it's pretty quick and pretty comfortable. So first, as bare metal is an experimental plugin, you need to enable the plugin, because it's by default disabled. And so you go into the help about plugins dialog and enable the plugin. And after that, you have to restart Qtcreator. And then you go to the tools, options, build and run settings, and set up a kit. And I talked about these kits before, and you need to get a tool chain for your device, so you can either use a tool chain available, like the tool chain on Launchpad, embedded GCC tool chain. It's, for example, an ARM tool chain, but any GCC-based tool chain will do. Qtcreator also has support for LLVM as backend and some other tool chains, but I think you mostly might have a GCC tool chain. And yeah, you can take a tool chain from these build tools, or you can download one with your distribution. It should all work, given that it has Python scripting support. That's important. After you have your tool chain set up, you set up your debugger, and then set up a bare metal device. I'll just show that later on in the hands-on session. And then you combine everything in one kit of the type bare metal, and then you're ready to go. So that's basically all you have to do to have Qtcreator set up and running for bare metal development. So it's pretty quick by now, and it's, I think, pretty comfortable. So it's still experimental for a reason. I mostly use the bare metal plugin with cubes. That's the new build system for the Qt environment. It's quite new, but it's describing the build in JSON. So it's quite good structured, machine parsable, and I like it quite well. Then what's added new is CMake support, and there's quite some effort to improving CMake support in Qtcreator, but still CMake support is, I think, supported for several releases by now. So, but CMake support for the bare metal plugin is new from the last year. You can also use Qmake, but I would not recommend it because you have to set up a fake Qt, because Qmake always needs to have set up a Qt environment, and normally you don't run Qt on such puny devices. Okay. So the backend Qtc is using is the GDB protocol. So you need a hardware debugger which speaks the GDB protocol. I think the two open source variants I know is OpenOCD, ST-Link, and there are of course some commercial products which also have GDB support. Yeah, and if you have problems, there's a debugger log, and it shows you all the stuff they're talking about, if the backend's talking with the GDB backend, and you see pretty easy, if you know a little bit GDB protocol, what's going on. And it's pretty good for debugging. So if you have problems, it's a good idea to post that with your problem description. On Windows, there's currently a bug that you must use the asynchronous mode to control the debugger. But it's a good idea to enable this feature anyway, because it's, in my opinion, the better way to interact with the debugger. Okay, what's new in 2014? So there's a fast restart. So it's not possible to restart your debugging session without reflashing and stuff like that. But you can just press restart and the hardware resets your device and starts new, which is quite nice if you just were debugging and just noticed, oh, I stepped over the interesting part in my debugging session and I just noticed, oh, and then especially if you have a little bit more code to flash and your hardware debugger is not the fastest, depends on your setup, it might take some while to get you again to this position, and having fast restart helps for that. Fast restart is also enabled in all the other GDB backends. So for remote Linux, where you have a SSH connection to your device, this might also help in starting up a little bit faster. But it's not so crucial because most single board computers with Linux have gotten so fast that it doesn't matter too much anymore. But it's available anyhow. Okay, CMake support has been enabled for the bare metal plugin, and there's been pipelining support, which has been superseded by the GDB provider. I'll talk about that in a moment. The GDB provider support has not been written by me, but by Dennis Chinkov. Thanks, by the way, for that. It's does management of the hardware debugger backend, so you can start and stop your debugging session or your hardware debugger automated from the Qtcreator. Before you had to start your debugger externally, so now you can just start it and it's pretty easy. Starting a debug session is just one click, essentially. Okay, there are several run control settings, and the target release for this stuff is currently in the mainline development branch is 3.4 release, which will be released in a few weeks, months. I don't know exactly the time schedule. But the next release basically will carry this improvement. Okay. So that were the improvements done for the bare metal plugin last year. What the next thing on my list in improving Qtcreator, and that's the most requested feature, is make support. So currently generic build support is not enabled in bare metal. That's mainly because you need to implement an extra class for the generic plugin, and that's not been done for the bare metal plugin. And I was tinkering if it's not possible to change the generic stuff within Qtcreator so that you don't need to have an extra class for supporting generic stuff. So I was not sure if I just implemented plain down or just change a lot more in Qtcreator to enable that. But that's the next thing on my list to improve. And with that, with generic support, it should also then be possible to use Qtcreator for debugging the kernel, which would be quite neat, I think, because if you're doing some driver development stuff and so on, you could then use it, for example, using BeagleBone with onboard. The white version had an onboard debugger, for example, and then you could directly use it for debugging the Linux kernel. One thing that would also be really neat to have is device view. So there's a plugin for Eclipse which has a structured device view. So you just give it an XML file which describes your memory and the register, for example, some hardware register definitions. And you say, for example, there at this position, there's an GPIO port, and then you can just click on it and change the values of the GPIO port with the mouse. I think that would be quite neat to have. Okay. Yeah, and then there's tracing support for ARM chips, but that's probably not anything which will be coming in the next years, so don't hold your breath. Okay, how much time do I have? Okay. So I forgot to get out my board. I just start up. So I have a small board over here. It has an onboard debugger and an ARM chip on board, so you can just use it directly with an USB port. It's also powered by USB, and you get something like that for about 15 euros or so it's quite cheap. And it also has, for example, this one has an acceleration sensor, which is quite nice for thinking about. So I have a small Qt-based project. Here you see, for example, how the Qubes project is described. And if you see over here, you see that I have an STM backend over here, and
actually, there's something on
oh, damn. I'm sorry. I thought I had mirroring. Okay. Right now, you see I have a project open, and if you go, oh, it's German. Okay, I'm out of time to switch the language, but this is setup over here, and these are the build and run settings. And if you create over here a bare metal device type, and then you can set up this stuff. And you have, if the bare metal plugin is enabled, which is being done over here by the plugins. There you can enable all the plugins you have, and you have to enable the Qube stuff and the bare metal plugin over here. And if you have done that, you have all these bare metal options down here, and you have a bare metal section where you can set up your OpenOCD stuff. So over here we have, for example, the commands for the OpenOCD setup on startup. So you can type in all the OpenOCD commands you need. And you have the commands for resetting, so you restart your device. This provider gets into the devices, and you have to set up an ST-Link device over here, and you have to select a provider down here. So you can, for every kit, there's a device, and at this device is then connected to a GDB server provider. And if you have this set up, then hopefully you can just start up. I just set so this is a really small project because so, and then if you go just to debug, you see, okay, it's starting up. Up here I've enabled the GDB protocol, which is only needed for debugging, but I just showed it. You have your debugging view over here. This is the fast restart button. You can also switch, for example, to assembly view, which is quite nice for optimizations and stuff like that. You have your variable view over here, and you have your threads back then. Okay, okay, that's basically it. Thanks for your attention.